Max Friedman, thanks so much for spending some time with us today. Share with our listeners a little bit about how you came to be involved in space.
It's kind of something I just fell into. Like, I knew nothing about CubeSats when I first started working on them. My boss, John Moore, at the Institute for Earth Observations, kind of just pulled me into it. I went to a high school that was like a trade school. It's called Burlington County Institute of Technology, and I studied electronic engineering. And he was good friends with my teacher, Miss Humphreys, and he kind of just came to her one day. He was like, "Hey, I need a student to work on this project," and my teacher essentially pushed me out the door to go start working for him, and it just kind of all went from there. I got involved in CubeSats. I started to meet with people in the industry and just have to cram this knowledge in my head and become a little bit of a small, just be able to like fully understand how CubeSats and space technology works. I just had to like really develop that. And it's funny because I've always enjoyed the idea of space technology and innovation in that field, but by nature, I'm like a robotics major, and I never expected to fully get involved with it in the way that I have been.
Well, yeah, I was just wondering. So you hadn't really heard about CubeSats up until then, right? I mean,
Yeah.
like they're a little bit more obscure than, say, like the notion of working on robotics.
So are you now, what year were you first recruited to work on the project? And am I right, you are a freshman?
Sophomore in college.
Sophomore. Yes. Tell us a little bit about the timeline of when you got started until now.
So I got started in December of 2019. I was a junior in high school. And I had just started then. And then, as we all know, in March of 2020, something weird happened where we all had to go hide inside our houses for a few months. And that kind of put a pause on the project. But that summer, I kind of came back, and luckily we had a big building. It was just John and I. He was upstairs, I was downstairs, and I was able to continue working on the project. And then I continued working through the school year and then full time over the next summer. And we were able to roll out version 1 of the CubeSat project. And then I went to my freshman year of college, and I still continue to work on that remotely, support schools who are actively doing it. We had a school in the UK who I was like constantly video conferencing with to walk them through the process of building the CubeSat and developing for it. And then this summer, we actually started working on the CubeSat version 2.
Tell me a little bit about this first program. So when you're saying that you were in, one location and John was somewhere else, what exactly was the project? To design an emulator, and maybe share with our listeners what an emulator is or does?
Yeah. So I actually have it right here. This is a CubeSat version 1. It emulates a CubeSat. It's essentially a really cheap version of all the components that would be involved in a CubeSat. And by cheap, I don't mean like they are bad quality. I mean that for what would go into space, it is significantly less expensive. The camera modules are identical in quality to what you would see on an actual CubeSat or a lot of CubeSats, but they're not rated for space. You basically take whatever the price of that component is, multiply it by like 1,000 or 10,000, and you probably have the cost of a flight-ready piece of hardware. But in reality, a lot of them aren't actually that different, and they just have that certification, that stamp. But this version 1 has a Raspberry Pi. It's a 3D printed case with 2 cameras on the bottom, an enviro sensor that measures environmental data like temperature, light, oxidation reduction. It also can tell us like the humidity, the barometric pressure, all kinds of cool features like that. And then we have a battery and power supply built into it. This isn't meant to go into space. It's not even meant to go in like a high altitude balloon. What it's meant for is just being able to build in the classroom, collect data from our ground station software, and just learn what it looks like to build space technology and learn more about data science.
So you are creating these with the goal of doing what? Getting them into high schools around your area, or?
Yeah, so we had some high schools in our area. Really, all levels of education are up for grabs here because people think it's hard to work with electronics and work with satellite technology, especially. They think, oh, you're working with satellites. That must be really advanced, and it is. But you'd be surprised what younger students are able to do. Think about like how many parents have to hand their kid their phone to solve a small problem they're having in settings. Kids intuitively understand technology and are able to start grasping technological concepts at a much younger age than people expect.
Right.
And if they don't start doing it young, it's going to be harder for them to do it later. So I really think that being able to give this to a kid as early as possible, or anything similar, they have tons of little kits for these things, even at the middle school and late elementary school age, it's honestly such an important part of development.
Right. I want to drill down a little deeper because it's my understanding. I think you're the one that designed the chassis, right? You made the 3D files for the chassis. So you're competent in 3D printing, STL files, slicer, whatever, Fusion 360, whatever toolkit you're using there. But you also did the schematic for the wiring. You came
Yes.
up with the wiring. Did you choose the modules? Did you choose the sensor, the rate? Are you using Wi-Fi on your current version?
So on version 2, we used Wi-Fi. Sorry, version 1, we used Wi-Fi. Version 2 actually has a much longer range a radio module. It's called LoRa. But version 1, the thing actually creates a Wi-Fi signal that your computer connects to for the ground station, which is why the range is limited, which is, it brings down the cost, and allows it to work better in a classroom environment.
Right. So what I'm seeing and what I appreciate is how multidisciplinary you already are, that you literally took something in your head and you created this thing in the real world. It's fantastic, because John would tell you, if he were here, he would say to himself, he says, I'm not an engineer, but you have literally become an engineer. And now, we'll talk about a little later on about where these kits are going to be going. And what a great opportunity you have for helping others.
Well, you mentioned John, Kevin, and I know that you worked with John originally, and your idea was to have these emulators as well. And he said right before we started that what you guys have designed is far superior, right, to where they were. So what are the key differences? Is it just that technology is advanced and you're able to use, like you said, the Wi-Fi, or what is it about your design? Or
well,
in your opinion, maybe even, Kevin?
I'll say what I know about A3SAT, because we started to build one and we paused, and we're still going to finish the kit that we have from you. I think that the engineering that you did into putting it all together, you have more capabilities for one. I don't know about the unit cost comparison from 12 years ago to the one you guys have now, but if you're close to the cost we were back then, I feel like you've really done a good job, because, accounting for inflation, you're better than we were, with inflation. I think it's about functionality, and I think it's really about the way that you and your teammates work to make a dashboard that accompanies your ground station, if you will. I think you've got the total learning package. All you need now is some instructional videos, and
put it on Teachable and sell a kit.
A teacher with zero background could take your kit and have a great tool for starting out.
Exactly. I think one of the biggest things that's kind of changed is that there's a lot more options for like off-the-shelf hardware. Version 1 is completely off the shelf. We don't have any, other than the frame, which you can 3D print, so I don't really consider it that, is nothing proprietary. It's how they're connected and the software that runs on it that is. And I think that from when you guys originally started to now, a lot of things that have changed are the Raspberry Pis. They're an amazing tool for development, especially in the classroom. We're having an issue right now where there's a supply chain shortage, and the cost of Raspberry Pi is like 4 times what it should be. But when it is what it's supposed to be, which is about like $35, I believe the cost of the version 1 was under $250.
Yeah. Did you work with Raspberry Pis prior to spending time with John? What preparation did you have prior to meeting John and being handed this chance to build something from scratch?
So before I met John, I had taken basic electronics classes. I had worked with Raspberry Pis since I was in middle school, and I had been working with 3D printers since a little bit before I started working with Raspberry Pis. So I was very familiar with CAD and felt comfortable with that, and being able to design these things on my computer and make them physically. I was comfortable enough with the Raspberry Pi, but the idea of bringing all of this together is where I struggle, that integration. And I never successfully done it. And it's a funny thing where like I'll have these side projects, things that I want to do at home. And it isn't until you're suddenly working with a team or you're working as an actual job that you have the thought, oh, I need to solve this issue. Not, oh, I want to do this, I want to do it for fun, where you can bail on the project anytime, it's no big deal. Now it's, I need to work through these issues. So I would hit roadblocks that I had previously hit in other projects and had stopped in those projects. But I found that after, okay, I spent an hour or two trying to troubleshoot this issue, I suddenly make it past that roadblock and I'm further than I'd ever been in that sort of development.
I like how you look at it that way. It's like just how far between the roadblocks, right? Like you're going to hit another one.
Oh
But
yeah.
it's like I passed that one. It's
So
like a game, right? Like get to the
it's
next
also a good
level.
statement about perseverance and pushing through, doing what it takes to get to the answer to your problems. So now you're in Boston, you're in college. Tell us a little bit about what your plans are. I know you mentioned robotics, but tell us a little more about your current education.
So I'm studying robotic engineering at the Worcester Polytechnic Institute. And honestly, I chose robotics actually kind of because of CubeSats. So not because I see that robotics is inherently a part of CubeSats, but that through working at CubeSats, I learned more than ever that I love all aspects of development. I love the actual hardware. I love software. I love electronics. Being able to design every little bit of that is just so amazing to me. And I realized very quickly that if I did a major in mechanical, electrical, software engineering, I would have a very rough time in college. I don't think I've ever heard of a triple major. But so I found that robotics is something that's at the intersection of that. And it kind of allows me to shift between those disciplines and use whichever one is necessary at that time to bring the entire project together.
Yeah, and it's like intuitively creative as well, right? Like
Yes.
within it, you're building something and you're having to use parts to get there.
The other 2 degrees, now what you've described reminds me of the other 2 degrees I think have similarities. One is aerospace engineering, which is really materials, electrical, mechanical, and computer science, right? Or
Exactly.
computer. And then likewise, a systems engineer, I think of them as the ultimate in project managers, right? Being able to pull all the pieces together. But I can tell you this, I'm going to send a link to your podcast to Kevin DiMarzio. He's a vice president at Redwire. And, they're doing a lot of the manufacturing in space. They were originally, they were called Made in Space. They did the first 3D printing in space.
I've heard of them. Yes.
Yeah. So
did they have the printer on the space station?
Yes. Well, now they're way
wow.
beyond that. They're the next era in our spacefaring evolution is manufacturing and living in space. So I'm going to make sure that Kevin sees your link because you would be a great Redwire engineer. And, robotics in space, robotics manufacturing in space is on its way.
Oh, so, beyond.
Like
it's
satellite refueling, resupply, repair, satellite refueling, and debris mitigation are probably going to involve robotics and autonomous vehicles right in your wheelhouse.
So if you're in your second year, if we have students who are listening who are thinking, yeah, robotics engineering sounds like a career field for me, what might they expect? Like say their first or second year, what can a student expect if they chose that as a degree?
I think that when you go into robotics, and when you go to any college class, you kind of expect like, oh, I'm just going to be sitting here doing a lecture. And I can't speak for every school. I can only speak for mine, but I imagine it's pretty similar in that, yeah, I have my lecture, but then I'm spending, 2-3 hours a day in the lab actually building a robot. And in my case, my course that I'm in now, I have to have a robot done by the end of the course. And I'm not saying, oh yeah, I have to spend 2-3 hours a day as a point of discouragement towards robotic engineering. I am saying that I get to spend 2-3 hours a day in the lab and work on this. I kind of view it most days, I view it as a privilege. Right. To be able to go in there and start problem solving something, even if it's as basic as, oh, I need to make this robot follow a line, or as complicated as I need to be able to have this robot pick up a ball and then launch it through a hoop, only using a camera to detect that.
So what is the requirement for this class? Tell us about the robot that you are building.
Right now, the robot that we're working towards is actually what I said, where there's about a minute or two of autonomous where the robot has to be able to identify colored balls on the track or on the platform and collect those balls. Remember which ones were what color, because there's red or blue. And then when it either launches or kind of pushes the ball through the hoop, it has to match the colored hoop that the ball was. And it's all doing that based off mostly vision sensor. We can also have like an ultrasonic sensor and a few others, but primarily the identification and targeting of the balls is just a camera.
I think it's interesting that you're getting to do that in just your second year. I mean, I think a lot of times some of these, the degrees, right, you might not get to do some of what you might consider the fun stuff, the real hands-on stuff until later down the road. So it's great that you're already getting to do that. I think too, and I wonder for students who are thinking, you've got so many prereqs that you might have to get through. Were there prerequisites to kind of get into your program?
Yes, there were a few prereqs, but most of the time you kind of have to take one or two of them because you've come in either with high school credits. I unfortunately didn't come in with many because just how things work. But I'm actually taking the intro class. So when you say like, oh yeah, you get hands-on only my second year, I'm getting hands-on in my intro class for robotics because I knocked out a bunch of prereq slash course requirements eventually in my degree path. Not necessarily for the original course, but I took those all my freshman year so I could just jump right into robotics and take it every term this year, getting a lot of experience with it at once. So yeah, in my actual intro class to robotics, it's just hands-on first day.
Do you have you gotten to tour or hang out with the Boston, what is it, the Dynamics company there?
No, I'm hoping to see him. There's a career fair next week. I'm hoping to see him.
They, for our listeners, if you're one of the few people that doesn't know, they have the anthropomorphized, two-legged, humanoid-looking Terminator is coming robots, and they also have the mules. The Army calls them mules, the four-legged that look like dogs that are just incredible technology. What would you like to spend a day hanging out with those guys?
I mean, I'd love to. I think anyone who works in engineering would love to. I know my school has a few of those robots. I've seen them like hanging by chains in a garage somewhere, but I would love to be able to see what they're working on.
So from your standpoint, a two-legged robot, that seems just to be upright and moving, with a sort of a bipedal kind of gait, that must be a lot of stability, the ability to keep your vehicle upright. Actually, I don't even know. Do we call it a vehicle or do we call it a robot? What is it?
I think any term is correct in that. What people define as a robot is very ambiguous and subjective. Some people say if it has a controller at all, it's no longer a robot. Others will define it as the vehicle itself. So it really depends on what your stance on that is.
So is that spinning noise we hear a lot with those type robots, is that some kind of inertial, an IMU or some unit like a gyroscope so it keeps orientation?
Yeah, I'm sure that a lot of times with those types of robots, especially ones that balance on wheels, they probably have some sort of a spinning weight that keeps it from tipping in one direction and can even apply jerk if necessary. I know that a lot of CubeSats have been doing that for orienting themselves in space.
Right. The jerk, by the way, is the third derivative of position as a function of time. Kids always crack up when they hear that for the first time. You have position, speed, acceleration, and jerk. I think you're the very first human I've ever heard use jerk in context.
Oh, wow.
Yeah. So what is the most, what made you choose the university you did? Obviously, Boston is, for pharma, for robotics, there's so much great education there. What made you choose the Boston area for your education?
He's just trying not to say Worcester.
Yeah, he is. He's avoiding it. He's very clearly avoiding it.
I'm going to say WPI. How about that?
Yes, that works.
WPI.
I think, well, I love New England. I think it's a great place. I grew up in New Jersey. I still live in New Jersey when I go home for the summer and visit my family. But I think New England's beautiful. And I chose WPI for two reasons. One, they're one of the only schools that had undergraduate robotics. It's a very rare undergraduate field. There were a few in my area, but WPI was actually the first one to implement that. And that's one of the reasons I chose it. And the second reason is because when I came on campus, I kind of just saw myself there. I looked at all the other students who were walking around. I'm like, I think I could fit in here. And I think I was absolutely right. I've had just such an amazing time, making friends, joining clubs. I'm in the high power rocketry club, and it's just such an amazing time. I've gotten into amateur radio. I just love it.
Do you have your license yet?
My amateur radio license? Yeah, I'm a general license and I'm in the executive board for
Is he going to be talking to Wolfpack anytime soon? Call him.
Well, I definitely am going to, you don't know it, but I'm putting the soft sell on you to talk to the team because I want my students to see folks just a little bit older than them that they can say, okay, I can do this. I want to do this. So yes. So you're doing high powered rocketry. Are you doing still solid rocket motors, or are you guys going to try to build some liquid engines?
Yeah, we're still solid. Our school won't let us work on liquid engines just yet. They're a little bit antsy, despite the fact that my school is actually the former school for Robert Goddard, the guy who's credited as the father of modern rocketry. We have
Yes.
buildings named after the man, and he gets commended for actually blowing up a part of a building on campus. He gets commended now for that. But
Yeah.
they are too afraid to let us work on it, despite also commending this guy. It seems a bit hypocritical to me.
No, I totally agree. In fact, his patents, he was so secretive, we probably could have gotten to the moon faster if we could have gotten a hold of his, all of the tech. But I believe he was the first to do was it liquid and a 2-stage? His patents were around a 2-stage rocket as well, right?
That sounds about right. And one thing I do know about him just historically is that there was a major newspaper, I don't want to say which one because I feel like I'll get it wrong, that published a paper reviewing a paper that he wrote about rocketry, stating there's no way rocketry could work. In the vacuum of space, you've got nothing to push on, so you can't, it won't work. And upon the first moon landing in 1969, that same newspaper posted a revision publicly stating that it appears we might have been incorrect.
Yes, that's fantastic. What's your ideal job when you graduate? Are you going to grad school, or do you want to hit industry? What's your happy place?
I don't know about whether or not I'm going to go to grad school. I think I might, but it really depends on what kind of the environment looks like at that time.
Right.
I would love to just immediately go into the industry, maybe eventually get my degree in my master's degree later on. But I think now, after everything I've been through in the last 3 or so years, a little less than 3 years, I kind of feel like I have to go into space-based technology. I don't mean that like, oh, I have to do this now. I've invested so much time. It's that like I've just kind of grown
Right.
around that now as an engineer,
Like
where
that path is unfolding before you as you.
exactly. That's a great way of putting it. I would love to work on like the systems of either rockets or space-based technology that come at the intersection of mechanical, electrical, and software engineering. It's just that's where I feel like I fit in.
Well, let's pivot then slightly to AMARIS. So you're kind of new to that program,
Yes.
which has been around for a little bit, but it's been just now kind of coming back to life again as the people have kind of gone off to college and you've joined that. What is your role with, well, for our listeners, AMARIS is going to be a lunar rover. It's going to be using CubeSat technology, correct? Is that still the case with what you're thinking? Yep. What is your role on the AMARIS lunar rover?
So the second they heard that I was a robotics major, they got all really excited because everyone else was either software or experimentation at the time. So now I'm working on the chassis and motorized design. So basically, how is the cube going to turn A into a rover? And then B, how will it be able to drive itself on the lunar surface after? And it's been probably the most like thought I've had to put into a design before. And I don't mean that as like with the CubeSat, the A CubeSat, I had to put thought into each individual piece. Where like, okay, overall, it took me a year to do this or a summer to do this or whatever, because each step I'd hit that roadblock or that thing where I had to spend a little bit of time. But just sitting there thinking about the overall design usually wouldn't take that long. Like I just hit the ground running. But with the AMARIS program, I felt like I spent hours just kind of thinking about how would this work at all? Like where do I even start from? I was driving up to Worcester to move into my apartment, and I spent the entire car ride basically in silence.
I'm sure that thinking in silence, thinking about like how the pedals would move, like
yeah, the wheels.
So I'm thinking like originally it had like those ski designs or whatever, right?
So yes, we gave a lot of consideration to that design. Let's see.
Oh, there you are. There you are.
Yep. No problem. We talked through a little bit of the.
Yeah, I was talking because like it gave me the opportunity to remember. Like originally they had kind of thought about ideas of like these skis or something.
Yes.
And then it was like
and the whole idea of folding it up was really just to save money with Astrobotic, because if we had a 1U footprint, we could be cheaper. But now I think we're at a place where we need to de-scope it and simplify it as much as we can to make it work.
So,
Because
so you were in the process of saying you were driving and thinking about it. So that's where we kind of lost you there. So
Okay.
did you come up with a solution?
Yes, so we have like two solutions that we're working on that we're both very happy with and kind of going through the pros and cons. So we believe we have something that's going to be very successful, and I think that just that the hours of thought that went into it, trying to like run through different simulations in your head, were very successful, hopefully.
Yes,
That's exciting.
what I'm most proud of, number one, I think you and Andres were the first two kids beyond our Wolfpack kids to buy into this vision
Yeah.
and to really be active. So I'm very pleased and very proud of you for doing that. And what has been your experience working with these kids at other universities now?
You know, it's been interesting, like working remotely almost, where you've got people in different parts of the country and now the case,
In the
different time
world.
zones. Yes, now and around the world, so different time zones. And I think it's actually been really cool. Like it's kind of shown me that yes, am I working on hardware and is someone else working on software? But we don't need to be in the same physical place to be able to share these ideas. We can develop effective communication strategies so that we're all on the same page, even if we're not able to directly sit around the water cooler and talk about it.
Oh my goodness.
so
You know, when
cool.
you'll be together is at the launch.
Oh,
Yeah. There's
I hope so.
you will never forget when something carries something of yours into space. So the
Oh.
last thing I want to ask about is, and let our people know, our listeners know, that I got involved with a nonprofit in Colorado that was working with a startup company, and they had recruited almost 100 teams around the world, most of which in South America, to learn about emulators. And through a number of circumstances, that didn't work out with that startup company. And what I want to, and I'm going to announce, is that your A3SAT is such, I think, a remarkable learning tool that our goal now is we're going to use A3SAT to help train up kids from around the world, mostly starting out in South America and then Africa. So, I mean, that's quite an accomplishment for a sophomore robotics student, right? To have designed something that is now going to be used by kids around the world. What are your thoughts on that?
I think it's really exciting. And part of me has not really fully processed that because I'm just thinking about what needs to be done before that point. You know, right here, this is the board for version 2 that's going to be going out with this new endeavor. And this is perfect. Like it's working really well. We have some other issues that we're trying to solve and we're very close to solving. So I'm very excited about that. We think that it's all just software. So that's best case scenario. But as an engineer, I feel like I'm just thinking about that next thing, the next hurdle, as you said. And it's in a good way because I see how we're going to make it to that point, but I haven't fully thought about what happens next. And that's when things I feel like get exciting.
Yeah.
Well, I'm so glad to finally get a chance to chat with you. John has spoken very highly of you. You know, it was about 2009 that we met, and then Blue Cube Aerospace came around shortly thereafter. And John and I sort of went our separate ways for a few years, but now we've come back together because we had two different bodies of work we had to do, but now our work is now together again. I'm thrilled to be able to support you, the work you do, and I want to get the work that you've done in as many hands as possible for kids that really can't access the kind of space that you can, you know, at WPI. But I think it's fantastic. You're an outstanding young engineer, and I predict you're going to have a really good paying job here in a couple of years. So that's just my thoughts.
Well, one can hope. Thank you so much. I really appreciate it.
Anything that we didn't get a chance to cover in our final moments here, or worse, you know, like we always kind of end with the same thing, but if there's anything you want to share with our listeners to inspire them to kind of follow their paths kind of the way you have, now would be a great time to give them some final words of advice.
I just think like what people don't see is that not everything needs to be a lesson plan. You know, I don't think a teacher needs to know how something works to teach it to their students because they don't need to be the teacher. They can just let their students experiment. And I think it's whether it's in the classroom or at home, if students just get the chance to mess around with an Arduino or they mess around with a 3D printer, they're going to make mistakes and they're going to probably spend hours wondering, why can't I get this LED to blink? But once they solve it, that's going to be something that is now in their, in their toolbox to use later and grow as an engineer or grow in STEM or whatever it is they want to do. So I just think take that opportunity and either teach to yourself, or if you're a teacher, give yourself a chance to let your students learn something, even if you yourself don't know it.
Fantastic.
Excellent advice.
Or as we say, fail fast, fail forward, learn from your mistakes.
Yes.
Well, we very much appreciate you spending some time with us this afternoon, and we look forward to continuing the work together.
Thank you, Max.
Thank you.
And we thank you so much.